All right, so we got a quick video here where we are just really practicing the rules for finding the derivatives of sine and cosine functions, as well as exponential functions. We're not getting into the origins of these. We've done that in class. This is more about just if we had questions involving finding the derivatives, how we would go about them. Okay, so this should be on the quicker side. Just to refresh your memory here, what's going on, the way we're going to read this is, if we wanted to find the derivative with respect to x of the function sine of x, that turned out to be the cosine of x. In other words, saying derivative of sine of x is cosine of x. And then the same thing over here, we are taking the derivative of the cosine of x, and that turns out to be negative times the sine of x. Okay. Now, in terms of using these rules, let's take a look at a few different examples. So we'll go through A, B, C, and D one at a time here. But the first one here we have is y equals 2 times the sine of x. So if we take a look at this, just a quick something to think about here. This might be a little confusing, the fact that there's a 2. You don't need to write this down, but just remember, let's say we had something like this. Let's say we had a function that was f of x equals 3x to the fifth. Now, we know at this point we're going to turn that into 15x to the fourth. But what's really happening is we're going to say this is really 3 times x to the fifth. And then we can take the derivative of x to the fifth and make that 5x to the fourth. So actually, let's make a little more room here. So we have the derivative of f of x will be 3 times 5x to the fourth, which would then be 15x to the fourth, like that. Okay. Now, again, we typically kind of skip over this, but that's what's really happening. That the 3 stays there. We take the derivative of the x to the fifth, and then in the end, we simplify it and put them back together. We do the 3 times the 5. All right, so keep that in mind when we have this 2 times the sine of x. So it's really just going to be, when we take the derivative here, it's just going to be 2 times, now whatever the sine of x is, the derivative of the sine of x, which, as we know, is the cosine of x. All right, and that's it. That's really all there is to it. Let's try another one. With b now, what's going on here is we start off with y equals the sine of x over 2. And then a way to simplify that before we start finding the derivative is to rewrite it as 1/2 times the sine of x. Okay, so that's just another type of question you could see. All right, let's simplify the way it looks first and then find the derivative. So that's what we'll do here. And it's very similar to the 2 times the sine of x, except now we're just doing 1/2 times sine of x. So we'll call this y prime, a derivative of y is equal to, we'll just keep that 1/2 there. Derivative of the sine of x is cosine of x. So we could leave it like that. Or if you want to rewrite it kind of like where we started off here, where we started with the sine of x over 2, if you wanted to kind of put it back together again, you could do that. So this could be the cosine of x over 2, like that. Okay, both of those are acceptable. All right, moving on. Next up, we have y equals x plus the cosine of x. So let's take a look at that. We have y equals x plus the cosine of x. Okay. And on any of these, by the way, if you wanted to pause the video and give them a shot on your own, you can. But what we really have here is kind of the sum and difference rules. So, all right, let's take the derivative. We'll find the derivative of each one and then put them together. So, derivative of x, well, that's just going to be 1. And then the derivative of the cosine of x is the negative sine of x. So we could say plus the negative sine of x or just minus the sine of x. Okay, and that's what we have on that one. Okay, and finally, D. Let's see what we got here. We have y equals the cosine of x minus pi over 3 times the sine of x. Okay, this is D. Okay, so again, we'll just go with, we'll find the derivative of each one and then put them together at the end here. So derivative of the cosine of x, we now know is the negative sine of x. And then over here, well, pi over 3 is just a number, just like 2 or 1/2. So this is really just going to be minus pi over 3, and then derivative of sine of x is just the cosine of x. Okay, and that's that. So those are some different types of questions you can see uh, with having to find the derivatives of the sine and cosine functions. Okay, let's jump over now to the derivative of exponential functions. And again, just a refresher, you should already have this in your notes, but to find the derivative of e to the x power, it turns out it's just e to the x power. And that does seem a little strange, but let's just take a look at this again. I don't think you need to write this, but you can if you want to. What's going on is in black, we have the actual function here, f of x equals e to the x. And we're going to look at it at a couple different points here, at 0, 1, and then at the point 1, 2.72, or just 1, which is really just e. Okay, and so what's going on here is the following. If we were to plug in a 0 to the original function, well, e to the 0 power is 1. And then it turns out that the slope right at this point of the tangent line happens to be 1 as well. So the slope is equal to the value of f of x at that x value. Does that keep happening? It does. Let's go up here. So when x is 1, we plug it into the original function here, f of x equals e to the first power. Well, that's just e, or 2.72. And it turns out that the slope of the tangent line right there is also 2.72. And we'll see that that just keeps happening for every x value we have. That the slope of the tangent line is equal to the value of the function at that x value. Okay, so that makes these derivative questions on the easier side. So let's take a look at these three now. And the first one we have is f of x equals 3 times e to the x power. Okay, and let's just go about this. Well, we find the derivative now. Well, again, what we said before, that the 3 is just going to stay there, and then we'll multiply the 3 times the derivative of e to the x. This is, again, a little strange here, but the derivative of e to the x is just e to the x. So this is actually all done right here. It looks like the same exact thing. Okay. Next up, we have x squared plus e to the x power. That's that is b. So f of x equals x squared plus e to the x power. Okay, think about what needs to be done here. So, well, to find the derivative, we'll do each one separately and then add them up. Well, this is just x squared. It's not sine and cosine or e. So we'll just handle that using the power rule. So that's going to be 2x. And then we'll take e to the x power, find the derivative of that. And we have just discussed that this is just e to the x power. So there we go. That one's all done. One more to go. This last one, we're going to combine some sine, some trig functions as well as the exponential. So this is f of x equals the sine of x minus e to the x power. Okay. So to find the derivative, we'll just do each one separately. Derivative of sine of x, we now know that is the cosine of x. And we'll subtract the derivative of e to the x, which remains e to the x power. There we go, all done. So those are just a couple of examples of things we can see in terms of having to find the derivative of trigonometry functions as well as exponential. Hopefully that helped. We'll get a lot more practice on this in class. And if you have any questions at that point, you can let me know. All right, thanks.